Hey guys, this is section 3.5, fitting a line to data. Here's your journal choice. I'm kind of excited because I'm on tour today. I'm not recording this at school. I am in my kitchen. So we're going to see how this turns out. If there's any quality issues, let me know. Here we go. Do you see that guy? He's supposed to be moving, but there he goes. That's cool. Okay, here we go. Objective and what's the point? Understand how the line of best fit can be used to make predictions, know how to find an accurate line, and how to eyeball it. I know that's probably a weird way to say it, but that's all I could think of. We're going to fit lines to data. This is really super important in statistics. I did this in my statistics class I took last year as a master's class. If you take statistics in the future, you'll use this. You've also used this in science. So this is something that will happen a lot, and I think you'll know what I'm talking about when we look at an example. Here's the words to know. Linear regression. This is a method of finding a line to represent data that uses all data points. The line of best fit, or it could also be called the least squares line or just regression line, is a line found by using regression. A line that comes as close to as many data points as possible. Basically what we're talking about here, I did this in PowerPoint today too, so this is a little bit new. So let's say you've collected data, you're in a science class, and your points kind of look like this when you plot it. Okay, and we kind of talked about this when we were modeling with the direct variation and inverse variation in chapter 2. I look at this. This is definitely not a line, but I can tell that I think the relationship should have been linear. Like if my data was 100% accurate, then this would have been a line. Or if there was no other variables like influencing the data I was collecting, maybe it was supposed to be a line. But it's definitely kind of like a direct variation, y equals kx type of situation here. So what happens is when we see the data looking this way, we know that's going to be a linear regression model. Later in the semester, maybe next semester, if it looked like a parabola, then we would say it was a quadratic regression. But today we're only dealing with linear. Okay, it has many different names, and that's because these are the way you find it. Line of best fit we use most of all, especially in the science. Basically what we're doing is we're fitting a line in here, and this is not I'm eyeballing it right now. I'm going to pick a way to put in a line so that it comes to as close to as many points as possible. And I'm saying maybe this. And what this is a predicting line. We'll use this to make predictions of where the data should be. Not all points are going to fall in line. It's impossible for them all to touch, okay? In fact, maybe none of them will touch. If it kept like straddling the line, then maybe it went right through the middle. Okay. The other word you need to know here is deviation. The difference between the actual value of the dependent variable and the value predicted by our line is called deviation. Okay, so here is my line of best fit that I just drew in there, and this is actually where the data is. This distance, and I think my pen's a little thick here, this distance is the deviation. So like here's where the actual data was, and here's where I predicted it to be. That difference, that change is deviation. So if you look here, where it probably has the most deviation, because this would continue forever, this point looks like it has quite a bit of deviation because it's pretty far from the line. If a point's really far from the line, we call it an outlier. I didn't put that in the vocab, but these are things you see. This one has pretty much deviation. Our goal is to minimize the deviation, and actually that's where the name least squares lines come in, because actually if you calculate this by hand, they take all these deviations and they're trying to minimize it, and they do this by like calculating the squares. There's all these little squares that they draw. I've seen it done a couple of times. I've never actually, I don't think, done it by hand. But you're trying to make the area of these squares the smallest as possible, because that means you have less deviation. And here it is. The sum of the squares of the deviations of its predictive values from the actual values is the least among all possible lines that could model the data. So basically, the real way they calculate this, they draw all these different lines, they find all these deviations, they square, and they say which line was the best. Okay, as you can imagine, doing this by hand totally stinks. So thankfully, we have technology that will do this for us. I don't know how to make that thing go away. Well, I hope it is gone whenever I go to the next page. We'll see. Okay. Of course, it's going to stay right there. Goodbye. You can go away now. How about this one? There you go. Okay. These are for people that have the TI-84s. This is how you do this if you have a TI-84 calculator. I do not have mine here. We will go over this in class. First thing you will do is you will enter this table into your calculator. You're going to hit Stat, and then you'll go over to Edit. L1 is the same as your X values, and L2 is the same as your Y values. Okay, you'll plot all these in. After it's all entered, you'll hit Stat Plot, which is second Y equal, and you'll make sure the first one's on. If you are having any problems doing this tonight, if you hit second plus, that's the memory, 7, 1, 2, that will clear all your memory and you can start over and you shouldn't have any issues. Otherwise, your stat plot might already be on if somebody's used your calculator before or whatnot. After you enter all your data and you turn the stat plot on, this is allowing you to look at these points on your calculator. You need to make sure that your window is ready to look at them. If you look, my smallest value seems to be 12. My largest X value seems to be maybe 315. So when I do my window, my X min, I'm probably going to look at maybe 10. Let's do my X max at 320. Same for Y. Smallest Y value, 859. So let's say Y min is 850. Y max, 63. That might be it. 6350. It doesn't matter, but that way you can ensure to see all the data points. When you have graphed it, you should see little dots. Now we're looking for that line that will best represent the data, our predictor line, because it will help us to make predictions. After you graph it and you see it, you're going to find the regression line. You're going to hit Stat again. If you hit right scroll over to where it says Calculate, you're going to select 4, which is linear regression, and it will say AX plus B. When you hit Enter, in some of the new operating systems, you might have to go all the way down and hit Enter or Calculate at the very bottom. It's going to give you an A and B value. What you do is you're going to plug this in. A is the same as our slope of the line. B is the same as the y-intercept of the line. Okay? And then whenever you wrote the equation, you would write y equals whatever that is, x plus or minus whatever that is. Okay? We will go over that tomorrow. I don't believe that I brought my calculator home. Of course not. So we will talk about this tomorrow. Make sure you can do this and we'll do an example in class. Okay, but these are the steps. You might want to jot those steps down in your notes, or else you might want to work through this data activity. Once you do it once, you should know how to do it, because you are going to need to know how to do this for the test. Okay, here's some info on the homework that I will give you tomorrow. And happy plotting. People with a TI Inspires, I'm going to link a YouTube video that is explaining how to do the same linear regression that you'll be able to follow. I'll try to find a TI-84 link as well, so that people who couldn't follow the oral directions would have somebody to watch. Okay, that's all. We will go over homework tomorrow. See ya.